Hey everyone, I'm Shah. Welcome to the Data Entrepreneurs Podcast. Super excited today because I'm joined by two people I've learned a ton from, Paul and Maxime. They are the co-authors of the LLM Engineer's Handbook, which is a great textbook and guide for anyone trying to build real-world LLM-based systems. Before jumping into the discussion, I think it might be worth Paul and Maxime just doing a brief intro for those people who maybe don't spend too much time on LinkedIn like me. Paul, why don't you give us a quick intro?
Hello, Show, and hello, everyone. It's a pleasure to be here on your podcast. A few words about me. I've recently written with Maxime the LLM Engineers book. I'm a AI machine learning engineer. I've done this for the past 8 years or so. I've walked through many roles, like I've been a software engineer, a researcher, a machine learning engineer, an LLMOps engineer. I guess I never knew what best suited me. So I really wanted to try it all. And from the past 6 months, I went like full time into content creation, and this is my new journey where I try to figure out how to do a business out of this.
It's a fun journey, and I've been kind of like watching along, and I've also learned a lot from you. Paul's done a couple of workshops with the data entrepreneurs on MLOps, and those were both very popular. And now he's turning into more LLM stuff and doing LLM ops. So here's the book. If maybe you recognize the cover, I just went and grabbed it. A lot of great expertise from Paul, and super grateful for him taking the time to join us today. And then Maxime, maybe a quick intro of your long history and experience in the field.
Yeah, thank you. Thanks for the invitation too. It's a pleasure to be here. So my name is Maxime Labonne. I am the head of post-training at Liquid AI. We do LLMs. We train them from scratch. So I'm in charge of the post-training part of the training. Outside of that, I've also made contributions to the open source community through articles, through the LLM course on GitHub, and through models like Neural Beagle, and also tools like Lazy Merge Kit. Pleasure to be here. And recently, I've indeed co-authored the LLM Engineer's Handbook.
Did you draw this yourself, Maxime?
Yeah. I've done pretty much everything. Sent it to the publisher, so they did like a better version of it because mine was more of a sketch. But yeah, that was the vision. There's a lot of Easter eggs in this cover.
Yeah.
Sometimes people ping me about them.
What tokenizer did you guys use for the title?
That you will find out only at the end of the book.
That's at the end of the book. Okay.
You have to read it.
That's funny. Well, let's just kind of jump into the conversation. So the title of the podcast or the discussion today is how to build end-to-end LLM solutions. One of the things that people are saying a lot these days is like it's never been able to build AI prototypes, but like the distance between a prototype and something that provides real-world impact, like a production system or an end-to-end solution or something like that, is a much different situation. So I'm curious to hear what you guys think. So starting with you, Maxime, do you see this age of like super easy and fast prototyping as like a bad thing or a good thing?
No, I think it's a really good thing in general because it allows you to take like very simple ideas or very complex ones from a paper, run through like Claude 3.5, for example, Cursor, anything, and get a working prototype very fast. So you're able to iterate a lot faster. Of course, there are also challenges about understanding code, what it does, understanding the ideas, especially if you take them from a research paper. So it's not like we're getting any dumber, I think, by doing that. It's just like a new kind of discipline in my mind to force yourself to challenge yourself to still understand what's happening, but for sure, like not having to write 1004 loops is improving my life overall, and I'm really grateful for that.
Things that may have taken you like hours to code up before now is just like a simple API call. You just write a prompt and Claude or GPT can do it for you. But with that comes new skills that you need to learn, which is like how to effectively check the outputs and maybe what we were talking about offline, like using docs as a way to generate outputs from LLMs and making sure the outputs are aligned and things like that.
Exactly. Like let me patent it in this podcast. Like doc-driven development is the next big thing. So like using your documentation as a way to develop your software. I'm a big believer in this.
Paul, I'm curious about what you think. On average, is fast and easy prototyping a good thing or a bad thing for developers?
I'm actually like 50-50 on this, so totally agree with what Maxime said, but I would like to add more on like when you want to productionize your system and how you see your program as a system. For example, RAG is a popular application, right? When you want to do a fast prototype using tools like LangChain, more often you do everything in a notebook. Like, so you load some data into a vector DB and then query it in the same notebook with a few classes and imports from LangChain. But that can be really deceiving in how you structure your code. I like to see LangChain and tools like this, like drag and drop in Python, because you just use 3 classes and you have a complex application. But if you want to extend it or understand it, as Maxime said, it's really complicated. And in the second part, I actually realized this 2 days ago. For example, many people still don't understand that a RAG application, for example, actually has like an online and offline side of things, right? And when you prototype and do these quick demos in LangChain, you don't see that. You'd have the offline pipeline that runs in batch, stream mode, or whatever, that pre-processes your data, chunks it, embeds it, and populates your vector DB. And you have like the online process that retrieves data and generates your answers. And these are 2 different programs that can run on different infrastructure, in different programming languages, and different everything. And that's what you encounter in real life. But on the internet, you don't say this.
This quick prototyping process, like everything living in a notebook, like what you were saying, you miss a lot of the nuances and technical details that are required to take it from this simple proof of concept to something that you might actually use in a business setting or some real world setting. And I feel like that's a perfect segue to the next question, which is like, what does it take to make that transition? What does that look like for you to go from this notebook and you've done the proof of concept, you had this idea, and now you see that it works decently well on your use case? How do you start taking the steps deploying this into the real world?
Personally, I think that the best way to start doing this is to actually get your hands dirty and start doing it yourself. This is the obvious answer. But the second answer is that I think trying to deploy your code is a great way to understand these workflows and how these systems work. Because let's say that you just started out in this field, then by deploying your code, you actually have to understand that you're forced to understand how these components work between each other, and what components are decoupled and whatnot, and where everything needs to sit in the cloud. You have no other choice than to do that, to reach that point.
Yeah, so deployment is like a great forcing function to have good engineering practices and just like a good learning practice.
Yeah, exactly. Because, for example, to deploy, most often you can't do that in notebooks. You need to do that in Py files. You need to Dockerize your code. You need, like in the RAG example, you need like to write an offline process that populates your vector DB, and then like a RESTful API that queries that vector DB and runs generations. And you have no way to bypass this when you deploy it. You need to do it that way.
Yeah, okay. Maxime, what do you think? And I imagine this might be different in your work in like post-training, because I imagine there's a lot of prototyping and experimentation that is involved in that. But like, I'm just curious to hear your thoughts and experience on making that transition from prototype to some production system that many users can get value from.
Yeah, so it's not really direct with the post-training world, because in post-training, what you do is you really train the model. So the prototypes that you would make are really tools and things that help you to get the best performance, like maybe add evaluations, that kind of stuff. So in this case, it's fine if it's still a bit crappy, because it's not user-facing. So I don't think that it has the same challenges in terms of, for example, deployment. I think it's a really good one as like most more general purpose systems. It might also like push you to be a bit less serious about what the code that you write. And I think that's clearly like a potential downfall. But if you have to work with several people, you tend to structure things quite naturally to be able to support many people working on the same project. So I don't think it's a major concern for me.
I'm also curious about like, once you've developed the model, actually shipping an LLM. I guess we take it for granted because most people just use like a API like Together or OpenAI or something like that. But like when you're developing the model yourself and you're trying to deploy that model for inference, like what does that typically require?
There are 2 ways of doing it. It can be either local and you run it, like I say local, but usually it's like on an entire node or like on several GPUs, right? So you can run it in your dev environment to test it directly, like in your terminal, whatever. Or you can, try to deploy it in a more robust settings, so like an internal platform to test it. So at Liquid, we have a playground where you can try all of our models, and we can also use the same environment to test different checkpoints that we want to vibe check, for example.
And so these are servers you manage yourself, or you guys use like a cloud provider or something?
No, those are like actually it's a good question. I'm not too sure. I cannot answer this question.
Yeah, all good. I feel like a lot has changed probably in the public eye with AI. I feel like for a lot of people, AI didn't exist until ChatGPT, but of course, like it's been around for a while. But there does seem to be a qualitative difference between how we would build machine learning systems and now how we build LLM systems. Just kind of curious on what you guys see as the similarities and differences. So maybe starting with you, Maxime.
There are two ways of seeing it, in my opinion. One way is saying like it's just a matter of scale. LLMs just have more parameters than old school machine learning. And the other way would be to say like, no, there's a paradigm shift in how we use it. So I think like in terms of technique, in terms of theory, it's just like scaling. And in terms of how we use it, this scaling has really profound impact on how we architecture everything, because something like using APIs is now like really normal in this LLM world, but it wasn't that much used in the old machine learning world, or at least not as much. So it's really in terms of evolving a trend that we could see models getting bigger and bigger, more and more performant. Current LLM ecosystem is really built on this idea that let's not try to deploy a super big model, 70B model locally. It wouldn't work very well. And that also has an impact in terms of training. We really stopped doing training, even fine tuning, all the work that you can do in post training. It's like a fraction of the entire training. So we really stopped training these models from scratch, which is a trend that is also like not completely new. Talked about it in terms of transfer learning a few years ago. And now it's just like fine tuning. You take a very strong base model and you're just going to supervise fine tune it, preference align it on more data.
Two things stood out to me with what you're just saying. So the first was now you don't necessarily, you're okay with shipping like a really big model because you can just host it via an API and integrate it into the system like that. And then the second thing was the rise of this post-training, which is perhaps a new version of transfer learning or transfer learning plus some other things as well. And that's kind of like the biggest shifts in this new type of AI that we're seeing. Paul, curious what you see as the differences in building ML systems versus LLM systems as someone who's done both MLOps and LLMOps.
Yeah, I think doing LLMOps is a lot more hardcore because of the scale. Like even doing MLOps is a quite complex process because like machine learning systems usually are non-deterministic, and it's really hard to teach other people what they need to do to like respect your MLOps processes because you need a lot of structure actually to keep this deterministic structure, like to keep your configuration files in check, like your code in check, your models in check, your data in check. There are like many things that you need to track. And if you don't have a very strong MLOps platform in place, which you usually don't, you're really lucky if you do, everything becomes a mess quite really fast. Because you work with people and every person has its own way of seeing things, right? And very often these things clash.
Basically, MLOps is hard without some kind of like platform that you're using to help facilitate it. And then LLMOps is also hard, but it's much harder just because everything has gotten bigger.
Yeah, but the twist is quite interesting. I think it's harder because of the scale.
Yeah.
But at the same time, LLMs are more flexible, right? So as you said, guys, you rarely do training or fine tuning. Maybe you do fine tuning, but there are many applications that don't even do fine tuning at all. Like we live in this machine learning AI world where for many applications you don't need to train any model at all. In that case, you use an API. So basically the scale problem actually is reserved only to some particular companies that do fine tuning. And for many companies, you can like externalize fine tuning. It's more than enough like to use the fine tuning API for many basic use cases. So then LLMOps for many companies actually boils down to like guardrails, monitoring, tracing, versioning your prompts and all of that. And actually the interesting part is that this resembles more to software engineering than AI engineering. And I think that's where people start to get like confused because many people from the data world don't do that much software engineering, but now over the night they realize that they need all these software engineering skills to do like these agentic applications where you
Yeah.
need everything.
Yeah, that's really interesting. So you mentioned a few things with LLM ops, now that a lot of things are offloaded to an API. So it's like evals and guardrails and things like that. And I feel like we've mentioned this term LLM ops a couple times so far in the conversation, but I feel like we haven't defined it yet. How do you think about it intuitively or when you explain it to other people?
Well, it's a subset of MLOps. Obvious. No. So basically, as I said, MOps is about gaining control over your application, I guess. So it's about tracking your elements that are mutable, for example, over time, which usually are your prompts nowadays. In all like AI applications, you have your code, your model, and your data. And now you also have the dimensionality of prompts. You don't do that much feature engineering, you do prompt engineering, right? So the prompts are an important element that impact your system. So basically, you need to be very careful on how you track your prompts. Also, guardrails, I think it's in the space of MLOps. To be honest, I don't know why, because it seems like an application development element. But if you think about it, it's really related to observability and monitoring and these aspects where you want, again, to take control over your system and know at any time what happens inside it. So when it crashes, you can open a dashboard, look at a trace at the chain and debug it and see what's going on. I think these are two very important elements in LLMOps: versioning your prompts and doing monitoring different, using like these tools that allow you to monitor your chain, like OPIC or Langfuse.
Yeah, that's interesting. It sounds like the APIs and basically not having to worry about hosting the models yourself has led to this abstraction of the development process, which feels like it's blurring the line between software development and LLM ops or ML ops or something like that.
You can think about it that way. Plus that you need to implement many application needs. Like, for example, in these agentic systems, when you have tools that are not really AI, they are just pure software where you need to crawl something, you need to access a browser, you need to do something, right?
Yeah. Maxime, I'm curious about what kind of ML ops or LLM ops considerations that you have to make with the post training. Because even though fine tuning is less computationally expensive than training a model from scratch, like it's still not a trivial amount of compute. So, like, what are kind of the key considerations that come up in that process?
Yeah, I think that's a really big requirement actually in post training. It's really not an afterthought. And most of the tools that I've developed for the open source community are like kind of related to LLMOps because it automates a lot of stuff, automates evaluations, automates model merging, it automates a lot of things that are quite tricky to handle manually. And by automating this stuff, I feel like it also allows you to optimize things even faster. For example, like a project I've made is called Auto Merger, and the idea is that it will take models from the Hugging Face leaderboard, top models, and try to merge them together, right? And okay, we might overfit a bit on the benchmarks. I used like another set of benchmarks to evaluate the results. It was quite funny because you could see that, yeah, it was trying a bunch of things, a bunch of different techniques, and that incrementally increases the performance of the model until you kind of plateau at some point. But yeah, I want to say that everything that is done for automation, really creating not just one model, but the factory to create a lot of models is always good to take and always a really good idea to invest in early on.
So it sounds like you're using a lot of models in the post-training process to like help the merging or fine-tuning process.
Exactly. So you have kind of 3 steps: supervised fine tuning, preference alignment, and then like model merging somewhere. And yeah, model merging is so cheap that you can create a lot of checkpoints. So the problem is not creating the checkpoints. It's like evaluating them, making sure that they're good. So it's directly connected to the evaluation side. And the same is true with preference alignment. Usually you can make like multiple runs. It's not that difficult to do. So you have to orchestrate the entire thing. And this orchestration layer, I think, is something that is very valuable and directly connected to LLMOps.
Interesting.
Yeah.
Paul, did you want to add to that?
Actually, I have a question for Maxime. So, merging, you actually don't do any training at all. There are just some like means and additions between multiple models when you do merging.
I can do a model merging crash course.
Here we go.
Yeah, you have like different techniques to do it. You can directly average the parameters of a bunch of models. So like really weighted average. So you take parameter 1 in layer 1 of each model and you merge them together, right? And then you have more complex techniques based on task vectors. Task vectors are what you extract when you take a fine-tuned model and you subtract the parameters of the base model. So you have the difference between the base model and the fine-tuned model, right? This is your task vector. And you can do a bunch of combination with these task vectors too, because they kind of represent like the direction where you're going when you do fine-tuning. So maybe you want to go further in this direction. And if you do this, for example, you fine-tune a model in Polish, let's say, and you decide to extract this task vector and augment the magnitude, increase it. And so you're more polished than before. So you can do a bunch of crazy stuff like this, and you can combine different task vectors, you can rescale them, you can normalize them, and those are like different merge techniques, but it's kind of the same frameworks every time. So no, you don't need to retrain. What you do is really extracting information from the parameters of the model, and you only work inside of this parameter space.
So for example, if you want to build a multilingual model, you have these task vectors per language, and then using an alpha, you can tweak how English or how Polish or how multilingual a model wants to be. Amazing.
Techniques that are really specialized, because one of the problems that you can encounter when you do model merging is parameter interference. And it means that, let's say you have a bunch of models and you look at parameter 1 in your layer 1, and one say +2, but the other model says -2. And the third model says +2, and the other model says -2. So you feel like it should be 2 or -2, but it shouldn't be 0. So if you average it, you're going to end up with something with 0 magnitude. And that's not really the information that the parameter told you. The parameter told you this parameter is very important, 2 is a big number, and it must be in one direction or the other, but not in all. So there are different techniques to fix that, and you can work with consensus between the models. You can try to sum all the different parameters and see where it goes. If it goes plus, you will say, okay, well, it was +2. If it goes -2, then you go, if it goes minus something, then you will select -2 as the final parameter. So this is the kind of techniques that are used to combine efficiently different tasks, different knowledge, like multilingual, to create this kind of end multilingual model.
So I wasn't originally going to ask too much about post-training, but now that Paul brought it up, like now I have a ton of questions. So I understand this task vector idea when the model has the same architecture. So you have the base model and a fine-tuned model with the same architecture, because the math adds up. But how does this work in that first example of merging that you gave, where you potentially have different models with different architectures and you just simply do a weighted average of their parameters? Like, how can that work, like even mathematically? And then also just like intuitively, like, I guess I don't expect that to work because they're different models, different training data and things like that. So curious what you think.
No, this is a good question, and maybe I was ambiguous, but it's always the same model, same architecture indeed.
Okay, got it.
With all these techniques, it's always the same. There are like papers about doing it cross architecture. In practice, it doesn't work as well. So this is not really recommended. I will always stick to the same architecture. And even if you stick to the same architecture, you can see that if the models that you try to merge are too far apart, because one was trained like a lot more token than the other, it can also create like issues, and you might need like stronger merge techniques, like the ones I've I've talked about with consensus to try to reconcile that.
Interesting. Okay. Yeah, I feel like that gave me a whole lot of clarity on post training. But kind of coming back, because you were talking about the post training process and how evals are very important and how you had this library to automatically look at leaderboards and combine models. And then there was a potential of like overfitting on certain benchmarks and things like that. So what I'm curious about is like, how can we evaluate LLMs effectively? You know, especially when it's easy to overtrain on specific benchmarks, and also, you know, these models are so big, they've consumed so much data that maybe they've already seen basically every benchmark or task in some form or fashion. I'm just curious, like, how can we do evals effectively?
Yeah, evals are really the most difficult part, I think, of the entire pipeline because it determines your objective function and you optimize everything like the data, the training, the parameters, everything to maximize some kind of objective, right?
Yeah.
So the evals that you choose is really the thing that you will try to maximize. So you have automated benchmarks. It's like MMLU, it's like the Open LLM leaderboard. It's when you have a set of prompts and you have a metric and you try to extract the right answer in the answers that are generated by your LLM. So this is fine. This is good, but this is not how models are used in real life, right?
Right.
In real life, we don't do like MMLU. We ask a general question. We say option A is option B, option C, option D. We actually provide questions and we want the models to be helpful when they answer them. So another way of seeing this problem is trying to measure the chat capabilities, the preferences when you ask humans, do you like the answer provided by model 1 or model 2 better? Humans are very good at that. We're not very good at writing the answers. We're not very good at answering the questions, but we're very good at telling, hey, I like this better than that, right? So we can use that and repeat this process over and over again to be able to say, in general, people like model B a lot better, like 10, 20% better than model A. And I think that combining these two approaches with automated benchmarks and chat capabilities is the right way to have something more holistic. But in my opinion, it's still not quite there because when we think about models and LLMs, it's kind of difficult to think about the model without like the entire user experience, really like a product. And when you try to do that, then you will want to maybe look at the entire conversation that you have with an LLM because users, why do you talk to an LLM? Because you have some kind of problem that you're trying to solve. It can be something like I want to write an email. It can be something very simple like I want to fix the grammar in my sentence, or it can be something very difficult like I want to write an entire piece of software, right? It doesn't matter. You have a problem, you have a conversation with the model, and you will like your experience with one model better than the one with another model. And that is not entirely dependent on quality. It also like inference speed. It's also a lot of like extra features like web search, for example, that can be added to provide a better experience overall. And when we've said all of that, it's still not over because there's always like the system that you build with an LLM, but that's more like both side, like how to also evaluate the RAG pipeline and a lot of other things that are also essential to the end results that the LLM produce.
Yeah, so I feel like there are a few different layers of eval that you talked about. So like the first layer is like the leaderboards. So, like there's a clear answer, the data is readily available, and you can do it very quickly. Then there was this process of extracting human preferences, which is better on these open-ended tasks or basically getting like real world queries and getting real world preferences. But then there was like this more global level of evals where it's like, okay, it's not just about how the model behaved in this specific context, but the overall user experience, which I feel like now, again, we're kind of going into different fields outside of machine learning. So I guess the AI people have to start getting comfortable with like user experience and like software development and things like that.
It's true. It's great because like at the end of the day, you have to evaluate the app that you're building. And if your app has a RAG pipeline, like the RAG pipeline is an essential component of it. Like it's not because your model is better than another model that the entire app will be better overall.
Paul, I'm also curious about your thoughts on eval and how you think about it and how you think about building robust and effective evals for your LLM systems.
My thoughts align a lot with what you said so far, but I have some additions to it. But before going into that, I have one question for Maxime.
Sure.
So for doing this evaluation where you have two models and people have to pick the one they like most, it means you have people in your evaluation pipeline that on a daily basis that they look at that results.
Yeah, so this is exactly what the chatbot arena does, right? From LMSys, you have like a ton of users and they like to just give preferences because it also allows you to use LLMs for free. So this is one way of doing it, but in practice, it's very difficult. It's not scalable to have humans providing preferences. I need like a lot of them to be able to compare multiple models together. So what we do at Liquid is that we automated this process and we use preferences made by humans to calibrate judge LLMs. And these judges are the ones that we use in practice to evaluate our models compared to competitors. And that's a really, really strong way of doing it.
So I'm repeating just to see I understood. So you trained an LLM judge using preference alignment to further judge LLMs between each other, something like that?
You could do it, but what I meant by calibration is you can just use GPT-4o, for example. And what we want to do is to make sure that the preferences that GPT-4o gives us are aligned with what humans prefer. Because like maybe the model has like very weird preferences, right? And in this case, you might end up with wrong evals. So you need to have some kind of calibration to make sure that what is provided on average corresponds to what you expect.
And you do that through fine tuning, like supervised fine tuning, or is it just like put the preferences in the prompt or something like that?
Not even like we would just have like, for example, 1,000 human preferences, and we ask the same questions to GPT-4o, and we're going to see like the agreement rate, these kind of metrics that really provide an idea like, okay, like 95% of the time it's aligned. And in general, LLMs have really human-like preferences because they've been trained on human text, right? So they're like very close, but you still need to make sure that it's true.
Okay.
It's correct.
Coming back to the evals, I feel like we could talk about post-training and alignment, but I want to hear your thoughts on eval, Paul, and then we'll transition to Q&A. So people watching live, feel free to start dropping questions in the chat, and then we'll get Paul and Maxime's responses.
Yeah, so actually, I've implemented today evaluation for like an agentic system and had to go through this same thought process. And it's based on what you said. For example, tools like Opic or other like evaluation tools, I think they're mostly made to evaluate apps and not directly LLMs. And why? Because they're very optimized to get one input and evaluate that one specific input, which usually happens in an agentic system. Because let's try to imagine how you could evaluate an agentic system in batch. You can't, because an agentic system is not only based on tensors where you can easily batch everything and so on and so forth. So basically, as you said, when you evaluate the app, it's really nice like to have one class or one big component that you can see at the black box, put an input, it does whatever it does, it calls different tools, it calls a vector DB, it does what it does, then you get the output and you evaluate that based on your business needs, which can be really custom KPIs. For example, what we did in our book with this style metric, which verifies that your system writes like yourself, that could also be a business metric because that was one requirement of your system, but you can take it even further.
It's kind of, again, not thinking about input output of a single model, but you have like this whole workflow or this whole application that you have to evaluate end to end. And then, what was the style metric? Like, how did you guys evaluate that? Because I feel like that's something challenging to quantify.
I don't know if we implemented it the best way, but what actually Maxime implemented it. I will try to replicate what he intended. But basically, we use an LLM as a judge, GPT in our use case, and try to give a score from 0 to 5, let's say, and we try to explain as better as possible what happens for each score. Most probably, we should give more examples to it using real world data if you want like to make it even better. But as an example, I think that's how usually we use LMS judges. We put it to give some scores and hope it's the correct answer. And one big issue I've seen with this in production is that they fail. Like the output that they give is not a number, it's something else. Then you just get okay, for 5 tests you have these results and the five others failed.
Got it.
They're also non-deterministic. So
Right.
I think that you need a test set big enough to like reduce this non-deterministic aspect of evaluating.
No, that makes sense. So just like you write out clear instructions like a grading rubric, like what teachers might do, or like what people do in education, where this is what a criteria for a 1, criteria for a 2, 3, 4, 5, and then seems like that gives you decent results most of the time. Like how many failures would you get from, I guess, 100 examples or something like that? And yeah, feel free to jump in, Maxime.
Yeah, I think that style was like definitely the most difficult metric to implement, and I had like a lot of different versions of it, of the prompt to iterate over and make sure that it was correct. Because the thing is that we use GPT-4o Mini as the data generator and also as a judge. We did it because we wanted to keep things simple, right? And we didn't want to bankrupt the readers. But what it creates is that GPT-4o Mini likes GPT-4o Mini. It likes its own answers. So when you try
a big ego.
Yeah, exactly. So when you try to tell it, no, but I don't want to sound like GPT-4o Mini. I want to sound like this example. The model is a bit confused and can be like very easily persuaded to say like, no, I like my answer better than yours actually. So it was mostly a game of like trying to convince it to really stick it to the example provided.
Well, we're starting to get some good questions in the Q&A, so let's transition to that. Let's go to the first one from Malik, who asked, what is the first step when starting an LLM project for a specific business need? And I guess like whoever wants to take this, like feel free to jump in.
Yeah, I can quickly go through it. So I think that the first step is of course, the first step is to really understand your business need and your data. But that's like key before starting implementing anything, really like articulating what you want to implement, like doing some system design sessions and talking with people that understand the problem. So basically understanding your problem, where you can get your data, what the data looks like. And this is like standard steps. And also when you start implementing, I think it's key to build a very naive version of it end to end and build an evaluation metric on top of it. And then using that metric as a signal, you can further add stuff on top of it. Otherwise, you can start doing fancy stuff that you realize it's useless.
Right. Low value for a lot of effort. Nothing to add, Maxime?
No, I completely align. Like I think that, like you have all these classic project steps at the beginning, like talking to people and stuff, but like the next step is really building the evaluation indeed. At least that's how I see it.
We got another one from Malik. How do you handle scalability when deploying LLM solutions for high traffic apps? I guess this is like everyone's curious about scaling to the moon and production systems and things like that.
Yeah, I think the easiest way to do this is using APIs so far. Otherwise, it will bankrupt you really easily. Because to do things at scale with LLMs, you need a lot of infrastructure. And where you can get that infrastructure like fast and easy, using cloud vendors like AWS. But cloud vendors like the AWS bankrupt you really easily if you don't have a lot of cash burn. So the easiest and cheapest way to quickly scale is using APIs like Claude or OpenAI or Grok if you want to use something more open source, or Hugging Face if you want like to quickly host your own models.
I would also recommend like Open Router. I think they're really nice when you want to be able to switch models easily, because you have access to like all the big LLM providers, plus a ton of other models from Hugging Face, from a lot of other providers, and that adds a lot of value. It's the same interface, same everything, so I quite like it.
Yeah, okay, Open Router.
Not sponsored.
That's something to keep in mind.
Yeah, you also have Light LLM, the same principle, just another tool. But
Okay, cool. I'm just using OpenAI right now, so these are good things to call out. So Emily asked, what are some skills that are more traditionally attributed to software engineers that AI engineers need to be able to do in modern AI/ML engineering?
I can take this one maybe. So I think that yeah, we like AI engineers are really about like getting like the best structure. It's really important to actually think like a software engineer. It's really just the domain that is different, but it depends on what you mean by AI engineer because it's kind of a fuzzy term, I guess. But I think that most of it is really important. Like system design is super important. Writing unit tests is really important. Like best practices in terms of like software engineering, they're all very important to AI engineering. There's basically like nothing that should be left. In my opinion, it's mostly like another domain, another area with its own specific stuff that you need to learn and be comfortable with, like RAG pipelines, that kind of things. But in principle, like the core concepts behind it are the same. I don't know, Paul, if you agree.
No, yeah, totally agree. Just on like best practices, maybe I could add a few, which I think are super important. Yeah, first of all, writing clean code, understanding like how to structure code, the dry principle to always like have the code in one single place. When you start copy pasting code around it, that's the beginning of hell. uh, Understanding some basic software patterns like the singleton, the factory method, the build method. You don't have to overcomplicate it. Just like the basics. Understanding how to write classes, like some basic OOP principles, which are not Java. I heard that they're just good programming knowledge.
I feel like you named a few basic software patterns that I'd never heard of, so I guess I I have some software development skills I need to brush
Yeah,
up on.
I'm a software engineer by heart, so
Yeah, I
I
guess
studied all of this.
I'm a physicist by heart, so if we start talking about dynamical systems, I could contribute. Okay, so let's see. James asked, "Can you provide techniques to combat hallucinations?"
Yeah, the first one is probably like a RAG pipeline, but basically there are two definitions of hallucination that are important maybe to outline first. The first one is factuality hallucination. In factuality hallucination, the problem is that the model doesn't know the answer. So for example, if you ask for restaurants in a tiny village in Europe, the model, if it's especially if it's small, won't know anything about that, so it will hallucinate restaurants that will kind of fit with the theme, right? They're going to be like very credible, but they won't exist if you Google them. And the other kind of hallucination is faithfulness hallucinations. And this time it's when you provide extra context and the model still fails to deliver a good answer. So for example, here, if we give it the Wikipedia page of the town in question, there are restaurants listed, but the model fails to actually retrieve the correct information.
Mm.
So for factuality hallucination, it's very difficult to combat because either you can retrain the model, this is fine tuning, either you can provide more context with RAG, with like long context, with a lot of different techniques. And then you have faithfulness hallucination. And this time it might be because of the system prompt. It might be something that you can try to fix with like better prompting, that you can fix with a better RAG system that is more accurate. Instead of sending the entire Wikipedia article, maybe you can just send a paragraph about the restaurants. So those are the techniques that are the easiest to implement to find this. And the real solution is like pre-training a 1 trillion parameter model that will store like all the information in the world, right? But this is not really realistic.
Right. So RAG and fine tuning sound like the main things you got. Tools in the toolbox. Marinos asked, why are low code solutions for RAG and AI agents so bad? Microsoft Copilot Studio in particular. When will it get better? Should I just try a different vendor or are we too early for it? It's an interesting question. Not sure how much experience you guys have with the no code solutions, but any insights here?
Yeah, actually, I can talk from my near experience. So I started using, I think it's called Langflow. So when Lang and Flow come come together, uh, And I wanted to quickly experiment with building a RAG solution on top of my Notion database. And it just failed from moment zero because in my Notion database, I have all kinds of elements, for example, toggles, buttons, or whatever elements that are not supported by this low code. So they're very rigid, I guess. So if you need very basic needs, they're okay. But the next second, when you need something more custom, they crash. Langflow, it's nice that they give you the code and you can start tweaking it. And what I did, I quickly did something in there, took the code and refine it in my own code base. But that's not low code anymore, right?
Yeah.
It's just a quick way to give you a code snippet and use it in your own application.
Sounds like the data integration piece is like the reason that app failed. I had a similar experience with Zapier. Like I had a very specific automation I wanted to build between Calendly and Notion. They had an integration there, but they didn't specifically have the connections that I needed for that implementation. So it sounds similar to your experience.
And I think that's a huge issue because data will always be custom. And until we have like an AI agent layer that makes this connection dynamically, I don't think how we can solve it.
Maxime, any thoughts?
Yeah, I think that in general with these low-code solutions, you trade flexibility for ease of use, and usually this is fine if you want to do something that is like really a use case that they provide, but everything like above that is going to be quite painful unless you have like tools to really provide extra flexibility. But yeah, this is quite common in general. Like this is a known pattern with this.
As my old physics professor would say, there's no such thing as a free lunch. So you always got to pay for it some way.
But I think they're amazing for quick prototyping. Like you can sketch your idea in 10 minutes. Just get a rough idea of what's going on and then that's it.
Malik asks, what are some common mistakes teams make when building or deploying LLMs? How can they be avoided?
I can talk about the building part and maybe Paul can answer the deploying part. So by building, if we're talking about like fine tuning and this kind of stuff, I think that maybe there are unrealistic expectations about fine tuning in general, like what it can do, because you cannot use it to like teach an entire language. It would require too many tokens. And like we have to be like quite realistic about what we do when we fine tune a model. Like there are not a ton of scenarios. You can like change the tone, the format of the answer. You can add knowledge, but it's going to be quite superficial. It can be about your company, about yourself, for example. You can use it to distill a bigger model, so you can reduce cost. You can reduce latency with a smaller model that you fine tune. And you can like make it closer to what you expect, so you can increase the quality with that. But I see a lot of people doing things or trying to do things that are really outside of that, and this is when it stops working. LLMs are flexible, but there are still limits, and I think that in general, it's a good idea to try to be in a category that we know works, or to do like very easy, quick prototypes to make sure that the idea can actually work in practice and we are not chasing a unicorn.
Okay, so doing the quick prototypes to, even validate if what you're trying to do is feasible. Paul, any thoughts on this?
I think that the most important one I see people forget about is auto-scaling. So a simple auto-scale can save you tons of money, because, especially like at the beginning of your journey, because let's be realistic, you won't have many users in the beginning. So scaling to zero when most of the time your system is idle will save you like tons of money. And understanding that LLMs eat a lot of GPUs. So usually it's not like with a CPU where you can run like dozens of processes in parallel. Usually you can run one request per GPU. It depends, but let's say that 1-2 requests per GPU. And for that, you need to be really careful on how you assign your processes, do things like micro batching to really parallelize those processes, not how we do it with CPU, that you run multiple processes in parallel, but actually do micro batching to squash everything into the same tensor and process it like that. And other things, I think everything becomes a lot easier by just starting with serverless. That's like my best advice for people. Just start with serverless things like model, bedrock, Hugging Face inference endpoints, and move from there.
I just had like a ton of different ideas of common mistakes, but if I can just like squeeze two main ones.
Yeah, go for it.
On top of like doing fine tuning when it's not recommended, it's not caring enough about the data. Like instead of doing like parameter optimization and this kind of stuff, like it's always a better idea to spend this time improving the data, filtering the data set, making sure that everything is correct. Like data in general is really undervalued. And the second one is about evaluation. It's like starting the evaluation when the project is already done. So now, well, it's too late to change anything. We just have like a bad eval, and now like it's a deadline, so it's too late. Which is why it's very important to start with evaluation, or to have like just the wrong evaluations. Like we're not tracking the thing that actually matters, and it's also a good reason why you want to start early with the evaluation, because the first evals that you create, if they are custom evals, they're probably not the last ones, and you are going to iterate over the entire process, because you are going to see that you're missing some use cases, and they are like maybe bad prompts, it can be whatever, but you are probably going to have several versions of your evaluation. So it's also why you want to start early.
Yeah, I guess in a world of LLM API calls and easy prototyping, it's easy to forget about, the quality of your data and building evals from the start. But I feel like, that's going to make the difference between a crappy system and one that's pretty good.
What I like to say overall in life, that direction is more important than speed.
Yeah,
and this
that's good.
also stands here.
Well, that's all the questions from the chat. Thank you guys for joining and dropping your questions. Thank you so much to Paul and Maxime for taking the time and sharing their expertise and insight with us. And again, check out the LLM Engineers Handbook if you haven't already. I got my copy here. Oh, you got okay. So we all got it. So if you guys want to be like us, get the LLM Engineers Handbook.